Hello everyone, myself Krishna Pranav, and today I'll be discussing on spelling errors in emails, a small mistake with big consequences. Introduction to email communication in IT. Email is a primary communication protocol in IT environments, relying on SMTP, Simple Mail Transfer Protocol, for message transmissions across networks. In professional settings, email integrity depends on both technical accuracy, example, correct headers, encoding, and linguistic precision, including spellings. Spelling errors introduce noise into the communication channel, reducing signal to noise ratio (SNR) in information transfer, analogous signal degradation in data transmission. In distributed systems, miscommunication due to spelling errors can propagate through automated workflows, triggering incorrect API calls or misrouted tickets. For IT professionals, email serves as a formal log of decisions. Errors undermine credibility and may violate audit trail requirements in regulated environments. Impact of spelling errors on professional credibility. Spelling mistakes in email reduce perceived competence by up to 30%. As shown in studies using logistic regression models on recruiter response. In engineering contest, credibility is tied to precision. A single misspelled technical term, example algorithm versus algorithm, can trigger a cognitive distortion in recipients. Bayesian Bayesian inference model suggests that repeated spelling errors lower the posterior probability of the sender and expertise regardless of actual technical skill. In cross-functional terms, misspelling in subject lines or key terms increase email misclarification rates in automated triage systems by up to 22%. Professional branding in IT relies on consistent, error-free communication. Spelling lapses degrade personal and organizational brand equity over time. Technical consequences in automated systems. Natural language processing (NLP) pipelines used in IT ticketing systems, example ServiceNow, rely on tokenization and streaming. Spelling errors reduce lemmatization accuracy by up to 40%. Misspelled keywords in email bodies can prevent correct routing via rule-based classifiers modeled as finite state machines with transition failures. In DevOps environments, automated scripts parsing emails alert for incident response may fail to match misspelled errors codes, delaying MTTR, mean time to repair. Spelling inconsistencies in code comments or documentation referred via email reduce traceability in version control system like Git, violating IEEE 829 standards. Error propagation in distributed IT teams. In global distribution teams, spelling errors compound with time zone delays, increasing the probability of miscommunication as per Poisson process models of message lag. Misinterpreted terms due to spelling, example server versus server, can lead to incorrect configuration changes modeled as fault injection in system reliability engineering. Email chains with spelling errors in exhibit higher entropy in information content, reducing mutual information between sender and receiver in Shannon communication model. In agile sprint retrospectives, misspelled action terms reduce traceabilities in Jira backlogs, violating traceability matrix requirements in ISO IEC 25010. Quantifying spelling errors rates in IT communication. Empirical studies show average spelling error rates of 2.3 errors per 100 words in IT professional emails derived from corpus analysis using Levinson distance metrics. Error density follows a power law distribution where 20% of the sender accounts for 80% of total spelling mistakes, infit, in identifiable via Pareto analysis. Using n-gram language models, the perplexity of emails using spelling errors increases by 35%, indicating higher uncertainty in message interpretation. Linguistic and cognitive load implications. Spelling errors increase cognitive load of recipients, measured via eye tracking studies showing 22% longer fixation duration on misspelled words. Working memory capacity, modeled by Cowan's K equal to 4, is overloaded with decoding errors, reducing available resources for technical content processing. Dual coding theory suggests that spelling errors disrupt both verbal and visual mental representations, impairing knowledge transfer in technical training emails. Automated detection. Spell check algorithms. Modern spell checkers use probabilistic models like hidden Markov models, HMMs, to estimate the likelihood of word sentences, with Viterbi decoding for correction. Edit distance algorithm. Levenshtein distance. Compute minimum operations, insert, delete, substitute to transform misspelled words into dictionary entries. Content-aware systems employ n-gram language models, example trigrams, to rank candidate corrections based on surrounding word probabilities. Deep learning approaches use transformer architectures, example BERT, fine-tuned on technical corpora to detect domain-specific spelling errors in IT contexts. False positive rates in technical spell checking average 8% of flagging valid and acronyms or code snippets necessitating custom dictionaries in enterprise deployment. Integration with IT communication tools. Enterprise email platform, example Microsoft 365, Google Workspace, integrate real-time spell check using client-side JavaScript engines with server-side dictionary synchronization. APIs such as Microsoft Graph allow programmatic access to email content for present validation, enabling custom linting to rules for technical terminology. IDEs and code editors such as VS Code now include email drafting plugins with syntax-aware spell check, treating prose as a domain-specific language DSL. Chat oops tools like Slack, Teams use webhook triggered spell validation bots that scan messages before posting, reducing public facing errors. Human computer interaction, HCL perspectives. Norman's action cycle model shows that delayed spell check feedbacks disrupts the execution evaluation loop, increasing user frustration and error rates. Eye tracking heat maps reveal that users often miss spelling errors in high density technical text due to inattentional blindness during rapid composition. Adaptive interfaces using machine learning can predict error-prone users and enable proactive spell check, reducing prose correction by 31%. Case study. Spelling error in critical system. In 2022, a misspelled email critical instead of critical delayed response to a server outage by 47 minutes, costing $180,000 in downtime. The incident was modeled as a fault tree, with spelling error as a basic event contributing to top event system failure with probability 0.18. The postmortem introduced automated present validation by using rigorous patterns and dictionary lookups, reducing similar incidents by 92% over 6 months. Best practices for error-free technical emails. Implement a recent checklist, including spell check, tone review, and technical term validation, reducing errors by 65% in control trials. Use version control glossaries like in Git repositories to maintain consistent spelling of domain specific terms across themes. Conduct peer review for high stakes emails using collaborative editors. Example Google Docs with tracker changes and comment threads. Future trends, AI-driven communication assurance. Predictive typing systems use RNNs to anticipate and correct spelling errors before user input, reducing keystroke level errors by 55%. Multimodal AI systems combine text, voice, and screen context to detect and correct error across communication channels, enhancing coherence. Research in affective computing aims to detect user stress or fatigue via keystroke dynamics, triggering enhanced spell check during high error risk period. Conclusion. In IT, communication is not auxiliary but a core system component. Spelling errors represent latent faults in the human machine interface layer. The cost of spelling errors extends beyond perception, impacting system reliability, compliance, and operational efficiency in measurable ways. Adopting a system engineering approach to communication ensures robustness, traceability, and fault tolerance in information exchange. For future IT professionals, mastering error free communication is not optional, it is a prerequisite for technical excellence and professional accountability. Thank you.